Okay, so I'm going to be going over this last few questions that I am going to be covering here, which is 7 through 10. I think I'll probably do 7 through 12, actually, just because of the way that it breaks. So this is SAT number 4, section test, practice test 4, section 4, 7 through 12. Okay. And 7 is, it has a chart with movie sales. All right, so basically, probably the easiest thing for me to do would be just to put this in frame here. Let's see if I can get a zoom. Okay. So, sorry that you can see the answer beforehand, but basically it's asking, the table above represents 50 movies that had greatest ticket sales in 2012. What proportion of the movies are comedies with a PG-13 rating? All right, so now let's look here. All right, so what did it ask for? Comedies. All right, so you're in this column. And a PG-13 rating. So you're in this row. All right, and you have 4. All right, so the proportion of movies is going to be, let's go back over here. It's going to be number of movies with certain rating divided by total number of movies. All right, now we said that this, all right, if you look back here, is going to be 4. All right, so this is going to be 4. And now we just need the total number of movies. So if you look here, total is 50. All right, so it's 4 divided by 50, which is 2 divided by 25. And that's going to be A. Okay? So that's what 7 is. 7 then is A. Let me zoom back out here. Okay, so 7 is A. 2 divided by 25. All right. Now let's go on to the next one. 8. Okay, line L in the XY plane contains points from each of quadrants 2, 3, 4, but no points from quadrant 1. All right, so let's remind ourselves what that means. All right, let's draw a Cartesian plane, X, Y. And now the coordinate naming system goes like this. This is section 1, this is section 2, this is section 3, this is section 4. Okay, don't quite know the reason behind it. I guess from angles maybe, but it basically goes around in this direction, counterclockwise. Okay, you just have to kind of memorize that. Now what it says is line L contains points here and here and here, but none that are here. So if you try to draw some lines, it is a line. It, you know, maybe it would look like this, or like this, or like this. These are, you know, all possible lines. Okay. It would have to look something like this. Okay. And the thing that you notice is none of them have a slope, right? That's, you know, how steep the line is. None of them have a slope that are going like this. Okay. And what that means is that none of the possible lines would have a positive slope, which means that the slope has to be negative. So the answer then is D. The slope of line L has to be negative. And again, you're just going to have to remember that lines that slope down this way are going to be negative, and lines that slope up this way are positive. Okay. So now we can go on to number 9. Alrighty. And again, I'm going to have to do the simplest thing, which is just show the table here and give away the answer. Sorry about that. But let's review what it's asking. So the table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, registered voter, so let's look at this. If a registered voter was 18 to 44 years old, all right, so it's 18 to 44, so that encompasses 2 columns. is chosen at random. Which of the following is closest to the probability that the registered voter was from the Midwest region? So Midwest is here. Okay. So, one of the main things that they're testing here on the SAT is just, do you know how to read tables? And that's, an important thing to be able to do. So, what you would want to do is you're going to have to add all of these columns up together, okay? And so we can do that. Why don't we just do that right here? So, again, I would do this with a calculator, but these numbers down here, these are pretty rough. So I can be rough with this and I'll still be, correct. Just because 10% is much different than 25%, which is much different than 40%. So what you're going to do is do 2,713 plus 8,159, and you can just estimate that. That's going to be about 8,000 plus about 3,000 is about 11. This is, use rough numbers here. This is about 11,000 plus 3,000, it's about 14. This is going to be 18,000 plus 5,000, it's about 23. And then this is 10,000 plus 3,000, which is 13,000. And now if you look at the sum, that's going to be 15,000 plus 48,000. So that would be, 15 plus 48, so that would be 63,000. All right. So what you want to look out for is this number right here, so 14 and 63. So you have 14,000, 14, I'm going to put a K, that means 1,000, 14,000 divided by 63,000, right? And again, you can just use your calculator. It's going to come out to some number about 0.235, something like that. But basically, you can estimate this. Just bump this up a little bit. 15 divided by 60, and that's just going to be a quarter. And so that's what your answer is B. B is the answer, and that's kind of how you would approximate it. Again, the principle that you do in a calculator is sum these columns and then divide the total of this divided by the total of all regions. But you can kind of even guess just without a calculator, and you'll be right on the money. All right, so these last few questions, zoom out here. I was just going to do up to 10, but they're all kind of related. It's all on the same page, so I'd rather just get them out of the way and just do it for you here. So you have a plot, and it's asking what is the life expectancy in years of the animal that has the longest gestation period. Okay, so I'm going to give you, again, the plot. Maybe I shouldn't have zoomed out, but I did. All right, so what is the life expectancy in years of the animal that has the longest gestation period? Now let's take a look at this plot. Alrighty. So it's asking, here you have gestation period and here you have life expectancy. So what is life expectancy of the animal that has the longest gestation period? Alright. Well, the longest one is just going to be one that's farthest out here, which is, let's see, this one's pretty far out, this one's, but it's, just look at it, this one's the farthest out. Okay, it's here. It says 60-day gestation period, and now if you read on the y-axis, the life expectancy is in between 2 and 4, which is 3, so it's 3 years, so it's A, okay? Now if you go over to 11, of the labeled points, which represent the animal for which the ratio of life expectancy to gestation period is the greatest, right, so life divided by gestation is the greatest, okay? And now what that means is that this is essentially the y-axis and this is the x-axis. So it's going to be the one for where y divided by x is really high. Okay, so let's look here. Basically what you're going to look for is one that has the highest slope. So there's point A, there's B, there's D, there's C. They're all about the same. Just as a test-taking tip, you could probably guess right away, just because A is so far away, that the answer is A, which it is. You could calculate this rigorously and say, okay, A, that life expectancy would be 7 divided by gestation period, which is about 20, all right, versus, say for example, B, you're going to have 8 divided by 45. D would be about 10 divided by 50. C would be about 8 divided by 50, okay? So even if you just look roughly here, and you can calculate this in which just whatever decimal is the greatest is going to be the answer, which is A, but you can just look at this roughly with fractions and say, well, 7 divided by 20, that's the same thing as 14 divided by 40, and these numbers are all about the same, and 14 is the biggest, which means that it's the greatest ratio, so again, the answer is A. These are just kind of ways to guess at what the answer is, and you're going to be right more often than not. If you're looking for, trying to get a 2400 or something, or 1600, and you want to do things rigorously to make sure, the way would be to divide the actual life expectancy by the actual gestation period, and whatever number is the largest, take that, but the answer will be A. All right, and now finally, if we look at 12, you have in the xy plane, the graph function f has x-intercepts, -3, -1, and 1, which the following could define f. So let's just, didn't even need to use this one. Zoom out here now. Alrighty. So this is, let's get a new one. So this is 12 now. Alrighty, this is the last one that I'll do. This is 12, and you have x intercepts at x equals -3, -1, and 1. And so what that means is you're going to have some type of function, and it's going to intercept the x-axis at -3, -1, and 1. Okay. And what that means is that when x equals -3, y equals 0. When x equals -1, y equals 0. And when x equals 1, y equals 0. Okay. And so now, if you look back at the options that they give you, right? Clearly the answer is C. Sorry, I circled that for you guys. Didn't mean to spoil the fun. What you want to do is plug in these values in here and see if you get y, f of x, y equals to 0 for these values. So for A, if you plug in -3, you're not going to get 0. If you plug in -3 to B, you're not going to get a 0. If you plug in a -3 to C, this you're going to have, let me do it out on the paper right here. You're going to have f of x equals x minus 1 times x plus 1 times x plus 3. But because x is -3, this is going to be 0. And since you have 0 times something, that's going to be 0. So that works. And it actually works for D also, because here's +3. So -3 plus 3 is 0, so that's going to work. But now if you plugged in +1 to f of x, right, for D, you're going to get 1 plus 1 squared times 1 plus 3, which is not equal to 0. But if you plugged in here, this 1, so +1 minus 1 is 0, times 0 times anything is 0, so that's going to be 0, so the answer is C. Alrighty, so I hope I've been helpful for section 3 and part of section 4. If you have any questions, I think I'll have contact information somewhere. You can either reach out to me or someone else to answer some extra questions. And again, I hope that my tips have been helpful. Thanks for listening.